Good afternoon, everyone. Welcome to this Advanced Steel introductory session where we're going to be looking at advanced steel for timber. As always, before I start, could someone just confirm in the chat or in the questions that you guys can see my screen okay and that you can hear me loud and clear? Excellent, thank you, Anas, thank you, Mirslaw, perfect. Okay, so we will get cracking today. A little bit about me before we start. So my name's Rob. I'm one of the application engineers here at Greytech UK. I started off in the construction industry as a architectural metalwork and structural steelwork draftsman using advanced steel. During that time, I worked in 2 subcontract drawing offices, so that gave me access to work with about 30 different fabricators working on all sorts of steelwork type projects. I'm currently working as an application engineer for Greytech UK, providing demonstrations, training, technical support for your structural CAD packages. Software I look at includes Advanced Steel, AutoCAD, Revit, Navisworks, Recap and Fusion 360. So anything sort of in your AC collection to do with steelwork. A little bit about Greytech. So we are 30 years old, headquartered in France. We are quickly becoming one of the largest Autodesk partners worldwide. We have over 550 staff currently. We do have our own research and development center, so we've got 100 of our staff in there working on our own products. So the power packs and things like advanced design. And we are here to help you guys, our customers. So on our technical support, we've got a 98% excellent or good feedback, and that's across 50,000 support cases. And we've got we deliver over 3,500 training courses every year. So why Greytech? We are one of the only companies who can sort of help you in all areas of a project. And we've broken that down into what we call our 4 key pillars. So they are create, simulate, fabricate, and manage. So create is using the Autodesk products and enhancing them with the Greytech Power Packs, which we will look at today. Simulate is then taking that BIM model and actually checking that it will work in a real-world environment. So we have our own tool, Advanced Workshop, which is our own structural analysis package. Fabricate is then taking our BIM model through to our finished fabricated product and site delivery. So the tools in the Greytech portfolio for that are Advanced Workshop and Armor Plus. And as we mentioned earlier in the week, Advanced Steel sits in the Fabricate pillar as well, because we can produce all the fabrication output, which is what we'll finish our session with today. And then the final pillar is Manage. So all of your projects will produce documentation and data. Usually you need to collaborate that with a common data environment. And if you're working on 5 different projects for 5 different main contractors, you could have 5 different common data environments. So we have Greytech OpenTree that will do all of the hard work for you in those areas. Now we're going to be looking at timber structures in advanced steel today. This session is being recorded, so if you do have to dip out for whatever reason, the whole session is being recorded, or you want to review it again in the future, though the recording will get uploaded to our content portal. So we're now up to 60 plus webinars in our content portal, looking at all different areas of advanced steel and steelwork within the AC collection. Myself and Alec also produce regular blogs. So we will try and do a blog once a month with just tips and tricks and different workflows and different bits that you might not know about advanced steel. If you're a Greytech customer, we do have our Greytech Advantage portal. So it's our dedicated portal where you guys can download your power packs and your Greytech products, but it's also where you can watch on demand our Greytech events that we run every year. So our BIM Up conference, our 3-day conference, our Advanced Steel user group. We just finished this year, the 2021 user group a couple of weeks ago. So that is available to watch on demand. from your Greytech Advantage portal. And this is probably where you found this event. Any future events you can find via our greytech.co.uk events page. Okay, so what are we going to look at today? We are going to look at modelling structural timber, what we can do with different timber connections. We'll then look at how we can actually build our own custom connections. So even if you're watching this webinar and you don't do a huge amount of timber, I think you will find a benefit in custom connections. Then we'll look at the timber drawings, or we'll look at all the drawing output from the system. And then we'll look at lists and schedules. So the drawings and the lists and schedule will be the last sort of 10 minutes. The main focus of today's session is actually looking at the modelling. So why advanced steel for timber? Structural timber is just beams and columns. We already have timber sections defined in advanced steel. So it's not like we have to create an entire new library. And most of the time, structural timber is connected with steel plates with bolts and anchors, and then you might have plates welded to plates. And then we need to produce fabrication drawings and bills of materials. Well, that is standard advanced steel functionality. So there's no reason why we can't create these sorts of structures using advanced steel, because they're a mix of steel and timber, or even if they were pure timber projects, they're usually bolted with steel plates and bolts. So this is the model that we're going to be creating today. So if you are new to advanced steel is built on top of AutoCAD. So if you're doing your timber modeling in AutoCAD at the moment, advanced steel is built in the AutoCAD environment. So it is a familiar environment. We then model the beams and the columns as sections with a start point and an end point, and those are either steel sections or timber sections. And then we can apply connections automatically from a vault of 200 connections. If there aren't timber connections in there, then we can create our own custom connections. And that is what we're going to spend the next 45 minutes or so looking. I'm going to go and create these things. And then if we need to, we're not going to look at this in today's session, but we do have macros to place railings, ladders, and structural elements automatically in our model. We can use a Greytech customized template. There are plenty of blogs on customizing template files. And first thing we're going to do is put the project settings. So we're going to call this, make some new offices. We'll do Greytech UK. We'll do Steve as the designer and I'm the detailer. And then we're going to save this file. We're going to put it in our desktop folder. Greytech. Greytech training offices. Okay, so the first thing we're going to do is put some grid lines in. So we're going to lock ourselves on ortho. We'll make this 20,000 long. We're going in that direction, so we're going to say 3,000. And then we're going to go 2,000, 2,000, 2,000, 3,000. So that will give me my grid lines. We'll put a balloon around those. So we've got my grids that way. And then we're going to have our grids going the other way. And they're going to be 5,000, 5,000, 5,000, 5,000. And they are going to be the grids going the other way. So the first thing we're going to do is put our columns in. So I'm going to come down here and go other sections, and these are going to be 7 meters. And what I'm going to do is I'm going to scroll down here, scroll down, and you'll see in here we have timber sections. So we have glue lamp sections, we have solid wood cross sections, we've got stock square timber, timber claddings and timber purlins. You can add anything you want in here with table editing and things like that. So what we're going to do is we're going to go with glulam. We are going to do a 240 by 240. And then what we're going to do is we're going to change this to timber. Now we do have some timber grades in here. So in fact we will set these to that one. We can leave the coating as that. Set the positioning as center. And then we're going to set the naming to column. Now this is a timber. So I'm going to put this on the timber beams layer. So there's my timber column. Now what I want to do is I need a base detail in here. So we're just going to make this about 400 mil. And I'm going to make this a universal column. And we'll make it 254107. But this time this is going to be steel grade 355. And that's going to be galvanized. And then I'm going to call this a column as well. Now what we're going to do in here is we are going to put from our connection vault. So Advanced Steel has over 200 different connections in the connection vault. So we're going to put a base plate on. So we'll choose the right column. No, I don't want additional concrete elements. So what I'm going to do is we're going to call this BP1. We're going to make this 20 mil, and I'm going to shorten this by a value. I'm going to shorten that by 35 mil, and that will give me my pack and grout value. 450 all round is fine. We'll change the anchor bolts to 8.8. We don't want any washer plates in there. Those centers are fine. So what we're going to say is this is going to be 10 mil fillet all round, and that's going to be fine. Then what we're going to do is we're going to put an end plate on this. So we're going to put an end plate on here, and I'm going to say shortening is by the plate thickness, and the projections is going to be total from center, and we'll make this a 250 by 250 plate. So that is the basis of my connection. So if I do what's attached in there, you can see that we've got the basics of our base in there. Now what I want to do is we want to customize it for the timber connection. So I'm going to say right in here, cut at an object. So this is the object to cut to. Cut this down, and we want a 10 mil gap in there. And that will cut my column down and give me a 10 mil gap. Now I need to create the plate in the middle. So I'm going to move my UCS in here, rotate it that way, and then I can create a rectangular plate based on a center point. So my center point is going to be the node in there, and that is going to be 250 in the X, 300 in the Y, 240, sorry. Positioning bottom center, I'm going to put that in the middle. So that has now got my plate in there, and I need to weld this plate to this plate with that 0 point in there. So that is absolutely fine. You can say make that a continuous 8mm fillet weld. Now because this is a custom connection, we have this little tab in here with all these little building blocks. Now Alec has done a webinar on custom connections, and that can be found in our content portal. And I'm going to use the bolts or anchors or holes on a plate. So we choose the plate. It says in here, select any other connecting object. So we're going to choose that one. That will put those anchors in there for me. And I can say, right, it's 3 bolts in the Y. And we'll have those at 90 centers. And that's fine. So it's giving me those bolts. Now I need to do is put a slot in the timber, so we can come down to here and I can use element contour UCS. So this is the item to be modified, this is the item to cut to. Now that will give me that slot. So I can put a gap of 5mm in there, and then what I can say is I can say make this 7mm and 7mm, or sorry, 6mm and 6mm, and that will give me, if I do a distance, a 12mm contour. Now what we also want is we want these counterbored for the anchors, for the bolt, sorry. So what we're going to do is we're going to do a circular contour in that timber beam based on the node point there. Going to make it 25mm. Now that has worked out from the center of the beam. So you can see there we've got the center point. So in here I've got my boundary side 1 and side 2. So I'm going to limit side 2 to 0. Now I've got a 240 column, so half of 240 is 120mm, and I want it 25mm. So I'm going to say drop that down minus 95, and that now will put that contour to that point there. I'm going to rotate my UCS round about the y-axis, and I'm going to do the same on the other side, and that will give me my contour. If we have a look, this view, that will give me my contour there and my contour there. Now that won't work until we actually copy this around. So what I'm going to do is I'm going to use the transform elements, and I'm going to array these. So I want to array both contours because there's two, and I want 90mm in the Y, and I want 2 copies, minus 90mm in the Z, and I want 3 copies. And if we do a preview, you'll see that the bolts have now dropped down. And if we look at a realistic view, those bolts now have set that up exactly how we need it. So if I come in here and I put another column in, at 7 meters, too far, 240 by 240 timber, or can't remember what I chose, but we'll do that. Set that to column, and then set that to the correct item. What I want to do is I want to apply this connection over to here. So what I'm actually going to do is I'm going to do a copy base. I'm going to copy everything in there. We're going to start a new file. Now, what I'm going to do in here is I'm just going to clash check this. I'm also going to show me what's attached in the workshop to make sure I've got everything set correctly. And I also haven't set the model roll of this, so this is going to be a fin plate. So there's my checks all done. And now what I want to do is I want to create a custom connection. So I'll say beam with an end, and this is 240 glulam base. glulam column. And then what we do is we say select everything. So that's going to put everything apart from that connection box around it. So that will put everything of my custom connection on. Now I need to save this file into my GBR folder. Make sure it says program data, Autodesk Advanced Deal GBR, shared connection templates, timber connections. And close that down. Now what I can actually do in here is I can actually delete everything. And then in here I can say insert a connection template. We've got our timber connections and I've now got my glulam base. So choose the glulam and that will put everything on for me automatically. So in here we can, and then what we can do is we can copy it around in a group and I can copy it to this column and that will put the connection on for me. I must have had my UCS rotated round, so we'll just rotate that and that will spin that connection around for me. So I must have had my UCS set incorrectly when I placed that. So that is just some basic modeling and some basic custom connections. Now what we want to do is we want to put a curved beam across the top here. So we'll just lock myself in 2D and we can simply draw our construction points. So we can go from there. Oh, let's get rid of those. What we'll do, we'll bring that over, I don't know, 1750. We'll bring that over 1750. We'll draw a line from the midpoint in there, 750. Yeah, we'll copy that from the end point there to the end point there and to the end point there. Then we can draw our 3-point arc from the end to the end to the end, and we'll just delete our construction. We'll set our UCS back to world, and then we have this command in here. So if I have an AutoCAD line, I can choose beam from line, delete the selected objects, no. We want to then again change it to timber sections. So the last one was 240, so we'll do something like, I don't know, 450, 440. .450 by 240, and again we'll set it to top center, we'll rotate that, and that is going to be our rafter. It doesn't want to jump to rafter, so we'll come down here and we will go why can't I do rafter? Okay, we'll leave that for now. Come back to that in a minute. and we'll set this as a timber beam. Now what we want to do in here is we want to trim and extend these. So I want to trim these to the system line. So that is my boundary object. These are the ones I want to trim. And I didn't like that. So let's try that again. Trim to the face then. That's the boundary object. That's the bit I want to trim. And that still didn't work. Okay. So we will leave that for now. So I'm going to go ahead and create a custom connection for these two items. So I'm actually going to copy these two into that timber connections. Oh, I could have actually just done a copy base from 0, 0, 0 to 0, 0, 0, and then we can start to build that. So we can go cut to object, we can then cut with a 10mm gap in there. That will give me, let's say 20mm. That will give me my 20mm gap. And then what we're actually going to do is we are going to copy this plate up. So we're going to copy everything here. From the top point there to the midpoint in here. And then we're going to move that back down. $90mm. And then we're going to stretch this up. 350. And then what we're going to do is there, I'm going to do -175, and that'll just put those down. So this time we're going to say that's the plate, that's the connecting object, and again we will do 3 in there at 90 and 90. I'm going to do -175, oh no, 175. So if we do 350, 400, that will put those in there. And then what we can do is we can turn the features on here. That will do those. We can copy the previous ones, which will be those. And we can copy those from there to there. and that will give me that. So again, what we can do is we can say that's the object to be modified, that's the object to cut to. I want a 5mm gap, and I want 6 and 6. And we want to do the same in here. So that's the object to be modified, that's the object to cut to, 5mm gap, 6 and 6. So if we clash check this, it found no errors. That will give me that slot detail in the beam. And then what we can do is we can set up another custom connection that says 2 beams. So it's column first, then rafter. What do we want it to do? Column to rafter fin. Select the column, select the rafter. And we want it to do all of that. And then in our model, we can come in here, there's the column, there's the rafter. Now we can go and insert this connection again. We'll do the right hand one. So we'll do rafter column. And that will just tidy that up for us. So now what we can do is we can say, right, we want to copy all of that. So we can do all of that. Make sure we include additional connections. And then we can say we want to copy from there to there. We want 1, 2, 3, 4 copies. We'll do a preview just to make sure that's okay. And we're happy with that. So that's fine. And now what we'll do, we'll just tidy this up. We'll just select the join boxes. We'll just turn those off. So there's the sort of basics of our portal. So now what we're going to do in here is we are going to have a steel structure in the middle. So we're going to use the monopitch frame. So we're going to choose point, point, and that will put our frame in for us. So we're going to say the height of them is going to be 4 meters, not 400. $4 and then the sections, we're going to change these to a UK square hollow section, and we're going to make them 120 by 8. The beams across the top will make those 254, 146, 28, and that is fine. So again, we can now come in here and we can put our base plate connection on. $20mm thick. We'll go 200. We'll make these Hilti HASs. we'll make these 220 by 220, and this is going to be base plate 2. And in here, we are going to use a fin plate connection. So we are going to go to the platform beams tab, and we are going to put a fin plate in. So choose the main beam, choose the secondary beam. That will put our fin plate on for us. We can then, so it's a default shape, that will remove that for us. 20mm bolts is fine, 50 and 50. What we'll do in here is we'll say 30, 30 and 3. And then what we'll do is we'll set that start distance to 30mm as well. So we'll just class check that. That will tell us if we've got any errors. Now if we want a cap plate on the column, we've got an end plate connection, so we can just use that end plate. You can say that's a 5mm cap by the plate thickness. And then we can copy these in a group to the other side. Copy these in a group to the other side. And then we're going to do what we're actually going to do now is we're going to model a beam in here from here. Now I want it down to there, so I just want the x-axis. So I can come to here and I can say just the dot x point. So I can choose that point there, that will put that section in. We can come and change it to a timber section. And we'll make this a 220 by 140. We'll position this top center. Want to make sure that this is timber. Naming this is going to be a beam. And we'll just put that onto the timber beams layer. And then we can copy that from there to there. So we need to copy this frame again. So when we go into transform elements, the copy functions have remembered the settings from before. So what we're going to choose is we're going to choose these two members, this frame, and that will actually, we're going to choose the intelligence, the frame, and the two members. That will pick up all objects. So I've only picked up 6. If I do include additional connections, it will pick up everything. So we'll preview this, and we're happy with that. Now what we need to do is the tie beams across the top. So I'm just going to isolate the beam and the angled line. Now what I want to do is I'm going to change my point type in here to something like that, and then I'm going to use the divide or measure command. So I'm going to say, right, divide this into 7 equal points, and that gives me my points where I want the tie beams. Now what I'm going to do is I'm going to position my UCS at the center of the arc that we have in there, and then I can draw a line from 0, 0 to that point there, and I can draw another line from 0, 0 to that point there. And then what I can do is I can use the AutoCAD dimensioning tools, and I can dimension between these 2 points. And if we scroll down here, the measurement is 6.26. So now what I can do is I can do a 3-point UCS from there to there, and I want my z-axis pointing. I will do that, rotate about that, and then we'll rotate that way, and then I can draw my beam, and I believe it was 4 meters. And then if we turn everything back on, oh, must have been 1 more meter, I can then use, from my Tools tab, my match properties, and I can say, right, match properties of that one to that beam there. So that will give me that. And then what I'm going to do is I'm going to set my UCS back to world, move it back to the end point down here, rotate this way, and then I'm going to use my polar array. And I want 1, 2, 3, 4, 5, so I want 6 in total. That's what I'm going to do. The angle between the items is that. So I want 1, 2, 3, 4, 5, I want 6. So we just do a preview on that. So you can see it's going the wrong way. So what we can do is we can say that it's -6. Do a preview. Those are all my tie beams. I can delete my construction. And then we can select these items. Oh, didn't set my UCS back to world. So do a preview again. Want to modify that, we only want 3 copies. And then there's my steel structure and my timber structure. So what we'll do, we'll just tidy this up and we'll hit save. Okay, so now that we have our members in, we might want to put a connection in, and we can use a standard connection. So we can go to the connection vault, and if we want a clip angle here, although we've got timber elements, we can still use the connections from the connection vault. So you can see in here we've got the angle cleats now. Let's put in 100 by 8 on. What we're going to do is set our horizontal bolts to 220 there, 250 even. You'll see that those bolts have gone in there. We've got those cleats on there. And then in here we have a double-sided angle cleat connection, so we can do the same thing. And we can, let me just see where those bolts are, horizontal, vertical bolts. We want 2 at 70 centres. So there's that connection in there. And then what we can do with 2020, we've got a new function. If I just isolate these items, we've got a new function here where I can select the joint and I can right click, and we have this propagate joint connection. And that's not going to work. Okay, so what we're going to do is we're going to copy those around multiple times in a group. So here's my main beam, and these are my secondary beams. And that will copy that round multiple times and put all the bolts in there. Okay, so I've done the same for these connections. We just copied those around. So there is my steel and timber model done in advanced steel using the advanced steel tools. So the last few connections we're going to put on are the fin plate between the column and the beam. So for that we have a custom connection. So we'll say insert connection template. In my timber connections, I've got okay, so we're going to insert our connection here. And in my timber connection, I have a 140 glue lam central fin. So again, we can go, chose the wrong inputs. So I've got my central glue lam fin here. We choose the column, we choose the glue lam. And that will put our central fin on. For the connection between the glue lam column and the glue lam beam, I'm going to use the column to beam seat angle. And I do actually have in there, you see that's put a nice little angle cleat on there. I do actually have a library entry here, so this is a connection that we would use a lot of. So I have saved it into the library. And we're going to go to a southwest isometric, and we're going to save that. So that's the end of the modelling. Now, I just want to run through some of the fab output for timber elements. So those of you that joined me on Wednesday will have seen bits of this, but advanced steel, once we finish the modelling, we then need to break the model down into single parts and assembly. So we need to do the numbering on the model, and the system will do the numbering on this sort of timber and steel combination in 3 to 4 minutes. Not minutes, seconds, sorry. And then we need to actually produce the fabrication details. So the part and assembly drawings will be run automatically, and again, you're looking at 2 to 3 seconds per drawing. And then we can look to create lists and schedules automatically. So for the last 10 minutes or so, I'm going to run drawings for everything, and then I'm going to look at how we can do timber-specific lists, steel-specific lists, and then we'll look at a few different export types for our timber output. Okay, we don't have a huge amount of time left, but we'll look at the basics of all the output. So what I need to do, I need to number my model. So I'm just going to open a numbering dialog, and I'm just going to let the system run the automatic numbering. Now, I haven't actually changed the prefixes in here, so anything that is glulam is called B's and C's, but we could change the name to TB for timber beam or G for glulams. That is something that can be set up and customized in the system. What we'll do, we'll run our drawing processes. I'll just run all parts A4 to A1 single bomb, and I'll do it for the whole job. So we'll have timber detailing and steel detailing. Now, the way Advanced Steel works with its drawings is I've pushed the button to run the drawings. My file in here is called Greytech Training, spelled incorrectly. The system creates a folder with the same name called Greytech Training, and then it creates a details folder, and this is the system creating each one of the details. So each one here is a fabrication detail, so it's at the moment one item, one page, and what the button I've pushed is all parts A4 to A1 single bomb. So what I'm saying is start with your part at 1:1 on an A4 sheet. Can it fit it on there at 1:1, yes or no? It'll then go 1:2, 1:5, 1:10, 1:15. I think it stops at 1:15. When it gets to 1:15, it'll then say, okay, I can't fit it on an A4 sheet. It'll then go through and try all those scales on an A3 sheet, A2 sheet, A1 sheet, and so on and so forth. So single is one item per drawing. The bomb bit on the end is bill of materials, so we'll get a bill of materials on the end of our detail. Now this will take 5 to 10 minutes to run on my machine, so as this is a recording here, I'm just going to pause the video, let it finish, and we'll come back when it's finished. And as soon as I did that, it finished straight away anyway. Now, the other thing I want to do is I want to run my assembly drawings. So again, I will click all assemblies, A3 to A1 single bomb, click OK, and then I'll let the system run the drawings. Okay, so my drawings are created. We'll save the model. We then want to go and look at our document manager. So if I open the document manager, it will just give you an overview of some of the drawings. So we'll start with some of our fittings, our piece parts. So in here we've got our steel plates. So any fitting that we have in the model, the system will create the view. Any holes that we have, we're looking at our main parts now. So these are some of our steel beams that we have in here. It will dimension the holes left to right, it will dimension the holes vertically, it will tell us the quantity, it will break down the material grade as well. I didn't have time to show it today, but I did model some timber packing in here as well. If we then go and look at some of our drawings now, these ones in here are our glulam. We can see actually the material is too long to fit in the table, but this is our glulam steel. So again, we've got cut lengths with holes in. We then got some of our fabricated columns with our contours in. Now, none of this has been customized. This is what you get out of the box. If I was doing a timber system for people, I would actually look to customize these drawings and set up some rules for the actual timber and when it finds contours and what it's going to do with these sorts of things in here. We've got some curved beams as well. And then we've got some of our cleats in here. So that's the automatic fabrication output. That took 3 or 4 minutes on my machine. It's not running the best today. The other thing we're going to look at is our lists and things. Now, in this type of project, we might want a list for steel and we might want a list for timber. So I've created these two queries in here, these searches. So I can tick the box to say isolate glulam, and that will isolate the glulam sections for me. I can then draw a window around those items, and then I could run a material list. And because I have just the glulam selected, it will just run a list for those glulam items. It's going to extract that information, and it's going to go put it on a schedule for us, or a list. Those are my sections, those are my overall lengths, and then what we actually need. You can see that is just doing it for the glulam items. And I can then do the same for my steel items. So I can isolate the steel, draw a window around it, and I can run a material list just for my steel items. Now, there are lots of different types of lists that we can run in here. I'm just running out of time today. Oh, I must have missed a couple. There's a couple of my timber packers in there. So I probably haven't set up my search particularly well. The glulam one worked fine. I think it's because it's looking for a particular material. But we are able to separate the model out. And then we want to create our CNC data. So I'm just going to check my settings in here. So if I want to run NC files for my steelwork, I can select all the steelwork, click the NC button, and that's the NC files created for my steelwork. I can also, depends what data your machines for processing the timber read, I can select these. These are just advanced steel beams, and I can click the NC button, and that will run the NC files for the timber elements. So it will create the NC files. The other thing you might be asked for, different file types for your timber. Now, if you have the power pack, so the power pack is Greytex add-in for advanced steel. We do have these export options over here. We have export parts to solids or export model to solids. One of our companies is a timber frame manufacturer, and they do want their timber in a SAT file, an individual SAT file for each piece. So I can say parts to solids. We can choose then, are we exporting the assembly or the single part? So we'll do the single part, and then we can choose whether it's going to a SAT file or a DWG, so that's just a 3D DWG, or a step or an IGES. So I know that one of our customers uses SAT file, so we will export to a SAT file, and we will export it, and I'll put it in here, and I'll create a new folder. And we'll call it SAT, and we'll delete that. If I go in there, I can say create those in there, click OK. Now that will then run through the export of each individual piece part to an individual file, and we'll get our SAT files. So if we go and look in our folder structure, if I go back in here, I've got DSTV. Here are my NC files. So this is for my steelwork, my plates and my beams. And then if I go into the SAT file, these are my SAT files, which would be read by the timber CNC machine, which we could then send off for manufacture. And that takes us to the end of today's session. There's obviously a lot more we could show. At the moment, today we're limited to an hour. So hopefully everyone found that useful. I'll keep the session running for the next 5 or so minutes. If anyone does have any questions, please type them in the question window now. Usually the first question we get asked is, has it been recorded? It has been recorded. It will be uploaded to our content portal within a couple of weeks. So I'll jump in ahead of any that question that comes in. Okay, well, I can't see any questions coming in, and I see a few people have left the session. So we will end the session there. Thank you very much for watching and for joining me. Keep an eye on our greytech.co.uk events page and our social media. We are just currently in the next round, or setting up the next round of webinars for December, January and February time. So once they are finished and announced, we will make sure all of you are aware of what webinars we're running. Once again, thanks for joining me, and hopefully see you on future webinars.